Balvikan Bharati with Avilas Satra. Now we will move on to the problem number 25 in fluid statistics. Okay, so the problem number 25 says, this is 25, an ice cube of density 900 kg per meter cube is floating in water is floating in water of density 1000 kg per meter cube. The percentage of volume of ice cube outside the water is how much? Okay. Now, as you can see, the density of the ice is less than the density of the water. That means from that we can already say the sum of the part is outside the water. It is not fully dipped in the water. The sum of the part is outside the water of the ice cube. Okay. So, but what is the percentage? Now, the first theory regarding the float. So, the law of float says what? The net force on object which is floating in any liquid is 0. So that means F net, if I say, is equal to 0. What is F net? The forces, if I draw the balance diagram, that is the weight of the solid downward and the upthrust upward. Apart from that, no other force is acting on it. So the net force is the solid weight of the solid minus upthrust, that is equal to 0. So from there you can say the weight of the solid is equal to upthrust. Its upthrust means the weight of the fluid dispersed. Okay, up to that we learned. Now further what? Weight of the solid, weight of the fluid, if it is completely dipped in the water, so then the weight is equivalent to the you can say the density are equivalent. But here the volume is not completely dipped. So in that case we can say the mass of the solid into the gravitational acceleration is equal to mass of the fluid dispersed into the gravitational force. So the G is not taking part for any deviation because G is acting on the both the cases of the dispersed water or the solid. So up to that we can understand. So what is the mass of the solid is made of the volume of the solid into the rho of the solid, and the mass of the fluid is the volume of the fluid and the rho of the fluid. So this is the unique formula by which you can say that whenever there is a body is floating, it will abide by this relation. Now we'll not go to the other part, only this we will use here. So if I use it, the volume of the solid is what? We don't know. What we have to find? The percentage of volume. Okay, so volume of the solid is, let's say, Vs, and the rho of the solid is 900. volume of the fluid is, we don't know, volume of the fluid, and rho of the fluid is 1000. So the volume of the solid by volume of the fluid, if I do, that I will get volume of the solid by the volume of the fluid is nothing but okay 1000 by 900, so that means 10 upon 9. Okay. So that means volume of, or the volume of the fluid by volume of the solid, if I do, it will be 9 upon 10. Okay. So that means volume of the solid is the solid that is dipping, that volume is constant, but fluid volume with respect to the solid volume is 9 upon 10 times. So that means what fraction if I want to take, so that means, so delta Vs by Vs into 100 into 100, that will be the percentage of solid dip. So what is delta S? Delta is equal to delta F, that means the percent dip into. So now for fluid dispersed by the volume of the solid is 9 upon 10. So what is the percentage of volume, the ice cube outside the water? So outside the water is how much? The volume of the solid, actual total volume, minus the volume of the fluid dispersed upon the volume of the solid, if I do, that is the delta S by delta V delta S, V delta S by Vs, means what is the solid percentage that is deviating from the actual, or let's say that means the volume, what is the means I mean to say, what is the volume of the solid that is outside, it is what, the actual volume of the solid minus the volume of the fluid dispersed, that will give you the delta Vs, means that is deviating from the actual solid of the volume. So now into 100 if I do, it will be the, give the percentage of delta V, this will be 1 minus Vf by Vs into 100 percentage. Now Vf by Vs is equal to 1 by 9 by 10. So 1 minus 9 by 10 is equal to 1 by 10 into 100 percentage. So that is equal to 10 percentage. So 10% of the solid ice cube, what percentage of the volume of the ice cube outside the water? So your answer will be 10 percentage. Okay, so 10% of the volume is outside. So first thing we have learned the theory on which, depending on which we have reached to this part. Now this part is the volume of the solid dipped. So you have to read the question carefully. Ice cube outside the, if it is inside the water, so this will be the fraction of the liquid inside. So 9 into 10 by into 100 with the percentage of the volume inside. So that is 90% will be the case. If it is instead of outside, it is said to be inside. Just see it first, the question carefully, then approach. Okay. So now moving to the problem number 26. A body floats. A body floats in water with 40% of its volume outside the water. Volume outside the water when the same body floats, when the same body floats in an oil, 60% of its volume remain outside the oil. The relative density of oil is how much? The relative density of oil is how much? Okay, this is the question. Now we already learned the theory in the last problem. So basis on the theory, when the body is floating, we know that for first case, when it is water, so if I use that formula, Vs rho s is equal to V water into rho of water. Now the body, I am talking about the solid body in the rest. So that volume of liquid upon the volume of solid is it depending on the water by solid is equal to rho s by rho w. So this is the fraction of body inside the water, because the solid disperse V water, volume of water this much. So when it is, this part is saying the fraction of liquid inside the water. What is outside the water? Just 1 minus something I will do. So I will get the so just keep it in mind. This part is the fraction of solid inside the water. So it has said the body floats the water with 40% of volume outside. This is very important to read. Since 40% is outside, the how much is inside 60%? So this value has to be 0.6. So while putting the value, you have to be very careful. This is equal to rho s by rho w. This is your first equation. So when it is oil, the second case, when the same body is in oil, 60% of the volume outside the oil. So that means in the second case, V of solid, rho of solid is equal to V of oil into rho of oil. So now similarly, oil by V of S is equal to what? V of S by rho of rho of oil. V of oil by V of S I'm talking about is equal to the rho of the density of solid by density of oil. So this part is said to be how much? So 60% is outside. So what much is inside? This is talking about the inside. So this is 40%. This is 0.4. So you have to be very careful when you use the formula, inside or outside. So now we have to find the relative density of oil. So relative density of oil, how will I get? Relative density of the oil is equal to the rho of the oil by rho of the W. So from this two equation, if I can eliminate the rho of solid, it will definitely get this ratio. So let me divide 1 upon 2, 1 by 2. So this will give 0.6 by 0.4 equal to rho s rho w divided by rho s by rho 0. So rho 0 will go up and this will go down. So this is the relative density as per the definition of that oil. So this is how much is equal to 0.6 means point will go up. So 3 by 2. So that means 1.5 is the answer. That has no unit. So only 1.5 is the answer. The relative density of the oil is 1.5. Understood? Fine. We'll move on to the next problem. That is problem number 27. 27. A sphere is floating in water, is floating in water it's one third part is outside the water, part is outside the water. And when sphere is floating in, and when it is floating in unknown liquid, its 3/4 part is outside the liquid, then find the density of the liquid. So this is kind of similar problem as we discussed in the earlier case, but still I will show it so that it could be a practice for you also, okay, and understand the earlier problem better with this example. Okay, fine. So for in case of the first one is water, second one is unknown liquid. So for water, if I consider the case, so that means the sphere, let's say the sphere's volume is VS rho S, that means it is somewhat solid, is equal to V of water rho of water. Okay, so now V of W by V of the solid, it is nothing but S by VW. So now this is said to be how much? This is the part which is inside the water, one third of part outside the water. So that means it is equals to be taken as 2/3. So 1 minus 1/3, this is 2/3. So this is your first equation. For unknown liquid, if I take same solid, same density, but this case unknown liquid and unknown density of the liquid. So this Vs, V of unknown liquid by V of S is equal to rho of solid divided by rho of unknown liquid. So this is again how much? 3/4 part of is outside the liquid. So what is inside? 1 minus 3/4, that means 1/4. This is equal to rho of S by rho of unknown liquid. This is my second equation. So in there is no need of the solid density, because what you have to find the density of the liquid, because density of water anyhow you can consider as 1000 kg per meter cube. If it is SI unit we are talking about, so any unit is okay. Either you take, if it is no problem, you can take 1 gram per centimeter cube. That also do, because there is no specific thing is needed in SI or CGS, so you can take the lower, so that the calculation will be a bit easy. So if we divide it, so rho S by rho W, this by this, so I am doing 1/2. So we'll get unknown by water, and if it is 1/2, it is 2/3 upon 1/4, so that will give you 8/3. So from there, the density of the unknown liquid will be 8 by 3 into 1, because the density of what is we have taken is 1 gram per, so this will be the gram per centimeter cube. 8 by 3, so this will be the answer, 8 by 3 gram per centimeter cube for the liquid. Okay, so fine, I will end up here, and the next episode I will move on to the problem number 20 and onwards. Thank you for now.